In this video, we're going to compute the values of some of the trig functions at some acute angles. So we're going to focus on some special acute angles. The first one of which is 45 degrees. Okay, so the reason why 45 degrees is special is that it's complementary to itself. So 45 plus 45 is 90. And what happens in the triangle, if I do a good one here, it's not great, but so if you have a 90-degree angle and then your angles that you're interested in are 45, it means that they're both 45. And this is an isosceles triangle. So what that means is that the length of the legs are equal. Okay, so remember that the trig functions are the same because they're ratios for all triangles with the same degrees. So I can make any triangle I want here. So why don't I just pick these lengths to be 1? Okay, now if those lengths are 1, the hypotenuse length is the square root of 1 squared plus 1 squared. So it's the square root of 2. So then now I have all of the sides. Let's say that this is my theta, okay, 45. I mean, it doesn't really matter what one you use because they're complementary. But then sine of 45 degrees. So if that one's my theta, this is the opposite, and this is the adjacent. But notice they're the same, so it doesn't actually matter. So it's going to be 1 over root 2. So the side length 1 over the hypotenuse length. And then some people like to write it with a rationalized denominator. So if I multiply by root 2 over root 2, this is equivalent to root 2 over 2. Okay, so this step here is rationalize the denominator. So you might have that ingrained in your head that you're supposed to always rationalize the denominator. If you do, your answer is going to look like this. So that's what you can use as well. So then cos of 45 degrees is also 1 over root 2 or root 2 over 2. So that's a special 45. Okay, other special angles are 30 and 60, and they sort of go hand in hand. Okay, so if you have a 30, 60, 90 triangle, it might look something like that. Okay, so here's my right angle. This is my 60-degree angle, and this one up here is the 30. Now the reason why this one is special is, so what I can do is make another 30, 60, 90 triangle right next to it. Okay, so that's also 90. This is going to be 60, and then this is not 60. 30. So that means this whole altogether is 60. So when all the angles of a triangle are equal, then you have an equilateral triangle. Okay, I should write this one was isosceles. So equilateral triangle has all side lengths the same. So this length equals this length, which is equal to that length. So again, you could pick anything you want. I'm gonna pick them to have length 2. Okay, now the reason for that, I'm gonna make this a bit bigger. Okay, the reason for that is so that, okay, so that's 2. It's so that each one of these, they're the same, so that they can be 1 instead of 1/2. Okay, doesn't really matter if you want to pick 1 or something else. Okay, it will be the same. Okay, so then we want to find the length of the height in the middle here. So you just use Pythagoras with one of the triangles. So that's going to be the square root of 2 squared minus 1 squared. So square root of 3. Okay, so then if I use, say, this 60 degrees, then this is my opposite, and this one is my adjacent. Okay, so I guess I'm doing the 60s first. So sine of 60 degrees is the opposite, so the root 3, over the hypotenuse, the 2. Okay, and cos of 60 degrees is going to be the adjacent over the hypotenuse, so 1 over root 2. Okay, now if you use the 30 degrees, so let's say up here, then now this one is the opposite, and this one is the adjacent. Okay, these are complementary angles, so you also know if I do cos of 30 degrees, it should equal sine of 60, so that's going to be root 3 over 2. But it's the adjacent over the hypotenuse, so yeah, root 3 over 2. And sine of 30 degrees is going to be the 1/2, so the opposite over the adjacent, over the hypotenuse. Okay, now once you have all of these, you can find all the other ones. Okay, so let's just make a table with all of these. So I'm going to do the in increasing order here. So 30 degrees, 45 degrees, and 60 degrees. Okay, now 30 is equal to 180 over 6. Okay, 45 is 180 over 4, and 60 is 180 over 3. Okay, why did I want to write that? Because 180 is pi, so if I want to convert to radians, this one is pi over 6. This one is pi over 4, and this one is pi over 3. Okay, so all I'm doing is changing the 180 to pi. Okay, and that, but you could also multiply by pi over 180. Okay, so we already did the sine and the cosine values for all of these. So for 30 degrees, sine was 1/2. Cosine was root 3 over 2. For 45, they were both root 2 over 2. Okay, and for 60, it's flipped. So this one is root 3 over 2, and this one is 1/2. Okay, now if you notice, I'm just going to put a little square root here, because obviously 1 is the square root of 1. So then you might notice, if you do them in increasing order, and you go sine and then cosine, a way to remember, they all look like square root of something over 2. So it goes 1, 2, 3 for sine, and 3, 2, 1 for cosine. Okay, so that's kind of a neat little way to remember these things. Okay, so then for tan, we just want to divide these things. So tan of, say, okay, so this is not for that. So tan of 30 degrees is sine of 30 degrees, so 1/2, divided by cos of 30 degrees, so root 3 over 2. So the 1/2s cancel, so this is 1 over root 3. For 45, I'm taking this thing divided by this thing, so that's going to be just 1, because they're the same. Okay, and then when I do this one divided by this one, it's just this thing flipped over. So this one's going to be square root of 3. Okay, now cosecant is 1 over sine. So all I have to do is flip the sine number. So 1 over 2 flipped is 2. Okay, 2 over root 2, or sorry, root 2 over 2 flipped is 2 over root 2, which is actually just root 2. And then this one's going to be 2 over root 3. Okay, now this one is 1 over cosine theta. So again, flip the cosine one. So this is going to be 2 over root 3. This one is also root 2. And this one is also 2. So like cosecant, but the other way around. Cotan is 1 over tan theta. Okay, so flip the tan theta 1. So this one's going to be root 3. This one's still 1. This is our 1 over root 3. Okay, so those are our trig functions for those special angles. Okay, so we should hopefully get to a place where we know at least these guys. Okay, so all of these we can find. We just did fairly quickly. Okay, but you want to know the sine and cos values, the exact values for these special acute angles, 30, 45, and 60. And there's going to be more once we continue. Now, you can also find these values with cheating, so with a calculator. So if you notice, the sine and the cosine values all involve the square root. Okay, well, except 1/2 doesn't really have a square root, but it could. So they have a square root in them. So what you can do is, suppose you want to find sine of pi by 4. Okay, so if you set your calculator, whenever you're trying to do these, you want to be in radian mode. Okay, so make sure you're in radian mode. Enter sine of pi over 4. Okay, you're going to get a bad number. Okay, so an irrational number. That's not the exact value. Okay, so if you want the exact value, what you can do is square what you get. So keep your answer, don't round it, but then just square it. Okay, so then what you're going to get if you square that is going to be 0.5 or 1/2. Okay, so then you're going to know, so then you know that sine of pi by 4 all squared is 1/2, which means that the sine of pi by 4 is the square root of that. Oh, it's down here. The square root of that, which then you get square root of 1 over square root of 2, or 1 over root 2, which is root 2 over 2. So you can find them that way if you want as well. For most angles that are not 30, 45, and 60, unless you use identities, which we're not going to do too many of, but sometimes you can use some identities to find the exact values. But often we just find the approximate values. Okay, now one thing you want to be careful of, so you might have noticed that your calculator does not have a button for cosecant. Okay, so or secant or cotan. If you want to compute those values, you want to remember that they are 1 over their appropriate trig value. Okay, so for cosecant, it's 1 over sine theta. So you could write that as sine theta to the -1. Okay, this is not the same. Okay, so just be very aware. This is not the same as sine inverse of theta. Okay, which you do have a button for in your calculator. Okay, so this one here is the inverse, which we're going to talk about later. So the inverse of sine theta. Okay, this one is the reciprocal. Okay, so that's 1 over sine theta. Okay, so you want to be careful that you want to do 1 over the thing. So you either do it as a fraction, or there is a button that looks like x to the -1. Okay, on my calculator, it's above the left bracket. So it does do it, but you could just do a fraction. Okay, now I'm going to leave these 2 examples for you to do. So try and figure them out. There will be a short video completing them with you if you get stuck.